You've seen it before. An ant carrying another ant. Not food, not a leaf, not an egg. A dead ant. And somehow, it doesn't stop. It keeps walking, focused, deliberate, like it has somewhere to be. Most people assume it's just instinct, a random behavior. But scientists who actually studied this discovered something far more disturbing. What ants do with their dead isn't just fascinating. It might be one of the most sophisticated survival systems ever documented in the animal kingdom. And the reason they do it will change the way you look at every ant you ever see again. Ants have been on this planet for over 130 million years. They survived mass extinctions, ice ages, the rise and fall of entire ecosystems. And one of the reasons they're still here is because of what happens when one of them dies. Most insects just leave their dead where they fall, but ants don't. And that single difference tells us everything about why they've outlasted almost everything else. Because what happens inside an ant colony after a death is nothing short of organized, cold, calculated survival. Here's the thing most people don't know. Ants don't carry dead ants because they're mourning. They don't feel grief. They don't even really know the ant is dead. What they're reacting to is a chemical. When an ant dies, its body starts breaking down. And as it does, it releases a specific compound called oleic acid. It's the smell of death. And to other ants, that smell means one thing. Remove this. Now. And most people assume ants carry dead ants out of some kind of loyalty or social bond. But in reality, they're responding to a chemical alarm that evolved specifically to protect the colony. That's why if you expose a perfectly alive ant to oleic acid, the other ants will drag it out of the nest while it's still moving. Fully alive, still fighting, being carried away like it's already dead. That experiment was real. And what researchers discovered next went even deeper. So where do they take them? Most species have a specific zone outside the nest called a necropolis, a graveyard, not random dumping, a designated location, sometimes used by the same colony for generations. And you'd think the goal is simply to keep the nest clean. But the real reason is far more strategic. Colonies that don't remove their dead collapse up to 3 times faster during disease outbreaks, because a dead ant is a biological bomb. Bacteria, fungus, parasites. One decomposing body inside a tunnel can spread infection to thousands of ants within hours. But here's where it gets disturbing. Some ant species don't just carry the dead away, they eat them. Certain species, like Formica ants, practice something called necrophagy, consuming their own dead, not out of desperation, out of pure efficiency. A dead ant still contains protein, fat, nutrients. Why waste it? And this sounds brutal by human standards, but this recycling behavior gives these colonies a significant nutritional advantage during food shortages. That's why in laboratory starvation tests, colonies that practiced necrophagy survived up to 40% longer than those that didn't. Death. Feeding life. But there's one species that takes this behavior to a level researchers didn't expect. And when they found it, they had to question everything they thought they knew about ant intelligence. Carpenter ants. When exposed to a deadly fungal infection, Ophiocordyceps, the zombie fungus, these ants do something extraordinary. The infected ant begins acting erratically. Other ants sense it immediately, not through sight, through smell. The infected ant starts releasing chemical signals that are slightly off. Not fully dead, not fully alive, something in between. And the response from the colony is surgical. Workers drag the infected ant out of the nest, sometimes while it's still walking, and deposit it far away from the colony's foraging paths. Not just outside, far, like they know what's coming. And you'd expect a colony to panic in the presence of a zombie fungus outbreak. But studies in Brazil found that carpenter ant colonies exposed to the fungus showed almost zero nest-wide infection when removal behavior was intact. That's why this behavior isn't just hygiene. It's a biological quarantine system, running, without a single decision maker, without a leader, just chemistry, and 130 million years of evolution. And that raises a question that's kept researchers up at night. If ants can do this automatically, what else are they doing that we haven't figured out yet? Here's the part that changes everything. In 2023, researchers from the University of Florida published a study on temnothorax ants, and they discovered something that had never been seen before. These ants don't just remove their dead. Under specific conditions, they perform rescue behavior on injured ants. They carry a wounded nestmate back to the colony. They clean its wounds. They stay with it. And in documented cases, the injured ant survived. And we've always thought ant death rituals were purely about sanitation. But this discovery shows the line between removal and rescue is being actively evaluated by the colony. That's why the same ant that carries a dead body to the graveyard might be the same ant that carries an injured one home to recover. The chemistry is different. The response is different. The decision is different. No brain, no consciousness, no emotion, just signals, and a system so refined it took millions of years to build. And here's the thing that nobody talks about. We have hospitals, we have funeral homes, we have quarantine protocols. Ants built all three, without a single meeting, without a single instruction, just chemicals and time. So the next time you see an ant carrying another ant across your kitchen floor, don't look away. Because what you're watching isn't simple. It's a 130 million year old system making a decision in real time. Is it removing a threat? Is it recycling a resource? Or is it trying to save something? The ant doesn't know, but the colony always does. And maybe the most unsettling thought of all is this: a system with no mind, no language, no leader handles death better than most human societies ever have. So ask yourself, what are we still missing that ants figured out before we even existed?